Okay, good morning. This is Professor David J. De Los Reyes. It's already May 13, 2023. The time is around 12:25 a.m. Okay, we are almost done with advanced mathematics. Okay, but for tonight, I will still be discussing some example problems of the last topic on advanced mathematics, that is the Maclaurin series of expansion application problems. Okay, let's proceed. I will check my calendar. Oh, it's fine. Our topic for this morning will be advanced math, lesson number 41. Okay, Maclaurin series expansion of sine of x. We are done with the cosine. We are done with e to the x. We derive the value of the value of e, meaning the base of the natural logarithm we are using by using Maclaurin's. And for this morning, we will be deriving the relation of what they call the sine of x by using Maclaurin series of expansion. Okay, let's proceed. The problem for this morning will be using Maclaurin series expansion. Derive the formula for sine of x. The function is sine of x. And find sine of 45 degrees up to 3 decimal places or up to 3 decimals. So, meaning to say, the problem is asking for sine of x equal to, using Maclaurin series of expansion, and the problem is asking for sine of 45 degrees. Actually, the sine of 45 degrees, 45 degrees is actually a special angle, because tangent of 45 is actually 1, and tangent is sine over cosine. So actually, the opposite side and the adjacent side for the 45 degree are both equal to 1. So actually, we could, from here, we could compute for the value of sine. Sine is actually opposite, okay, over hypotenuse. That is 1 over square root of 2. And 1 over square root of 2 is actually 0.707. So supposedly, what will come out here will be 0.707. Okay, but we must have to derive first the value of sine of x, okay, by using Maclaurin series of expansion. Okay, let's proceed with the solution. So if the given function is sine of x, I will place it here. Function of x is sine of x. Okay, let's try to take the first derivative. The first derivative will be the derivative of sine. And the derivative of sine is actually plus cosine. So f prime will be cosine of x. This is plus, because the derivative of sine is actually plus cosine. Let's try to take the second derivative. The second derivative will be the derivative of the first derivative. Okay, the derivative of cosine is negative sine. So actually, f double prime of x is negative sine of x. There's a negative sign over here. Okay, let's try to take the third derivative. The third derivative will be the derivative of the second derivative. Okay, so if we try to take the derivative of this, it should be negative open quantity. The derivative of sine is actually cosine of x. It is plus. So this is a plus or minus, this is plus, a minus and a plus will be minus. So the third derivative is actually negative cosine of x. Okay, it will still be negative. Try to take the fourth derivative. The fourth derivative will be the derivative of the third derivative. So it will be, if we try to take the derivative of this, negative. This is preceded by negative sign. Okay? Then we will try to take the derivative of cosine. And the derivative of cosine is actually negative sine of x. So a minus and a minus. So the fourth derivative is actually plus sine of x. This is plus. Okay? The sine is plus. And if let's try to take the fifth derivative. The fifth derivative is the derivative of the fourth derivative. If we try to take the derivative of this, it will be, since this is plus, there's no problem. Then the derivative of sine is actually plus cosine of x. So this is plus. Okay? Okay, let's review. Function of x will be plus sine of x. F prime will be plus cosine. F double prime will be negative sine. F triple prime will be negative cosine. F to the fourth of x will be plus sine, and f to the fifth of x will be plus cosine. We needed these equations here in order for us to compute for f sub 0 up to a certain derivative. Because in the resulting Maclaurins, we needed the functions when x equal to 0 for each of the conditions. Okay, for the first one, function of x is actually sine of x. So f of 0 will be sine of 0, and the sine of 0 is actually 0. The sine of 0 degree or radian is actually 0. Next one, f prime of 0. F prime of 0 will follow this. It will be cosine of 0. So this will be cosine of 0. And the cosine of 0 degree is actually, this is plus, right? So this should be plus 1. Third one, the f double prime of 0. This should be negative open quantity sine of 0. Right? This is preceded by negative sign. But sine of 0 is actually 0. So it doesn't matter now if there is negative here. A 0 times a negative thing will be a 0. Okay? F triple prime. F triple prime will be negative cosine of x. When x is 0, f triple prime will be cosine. This is preceded by a negative thing, right? Negative open quantity, cosine of 0. Cosine of 0 is actually 1. So 1 times preceded by negative sign. So this is minus 1. F to the fourth of 0. Okay? We'll follow this. Sine. Oh, right. It will be sine of 0. This is an equal sign. Okay? And sine of 0 is 0. Okay? F to the fifth of x, when x is 0, we'll follow this. It will be, this is actually plus, right? Preceded by plus. And the cosine of 0 is actually 1, preceded by plus. So this should be plus 1. So the values from f sub 0 up to f to the fifth of 0 are actually this. 0, this is plus 1. 0, this is minus 1. Then 0, it is plus 1. These are the needed values which will be substituted on the Maclaurin series expansion formula for us to get the value of the relation of that function by using Maclaurin series of expansion. Okay, I will try to check my camera. It's fine. Okay? Let's try to continue. Under Maclaurin series of expansion, sine of any function of x, this is function of x, right? Should be equal to f sub 0, f prime of 0 multiplied by x, f double prime of 0 over 2 factorial times x squared, plus f triple prime of 0 over 3 factorial times x cubed, plus f to the fourth of 0 over 4 factorial times x to the fourth, plus 8 to the fifth of 0 over 5 factorial times x to the fifth. So as you notice it, the first one should be multiplied by x, the second one. The next one will be x squared. Next one will be x cubed. Next one will be x to the fourth. And the next one will be x to the fifth. Okay? This is the Maclaurin series of expansion. And we now know all these values here. So it's just a matter of substitution now. So if the given function of x is sine of x, therefore sine of x now, okay, will be equal to f of 0 is actually 0. It is this. F prime of 0 is actually plus 1. So this is plus 1 times x, right? This is plus 1 times x. We are following this. Plus f sub 0 prime is actually 0. So this is 0 over 2 factorial times x squared. Okay, it is this. F triple prime of 0 is actually negative 1. Okay, so this is plus open quantity negative 1 over 3 factorial. 3 times 2 times 1 times x cubed. We are following this. It is negative 1, right? It is this. What's next? F to the fourth of 0 is actually 0. So this is 0 over 4 factorial, which is 4 times 3 times 2 times 1 times x to the fourth. Plus the last one, f to the fifth of 0. F to the fifth of 0 is actually plus 1. So this is plus 1. Right? All over 5 factorial. 5 times 4 times 3 times 2 times 1 times x to the fifth. Plus, there are some minimal values over here. We will just stop up to the x to the fifth. Okay? And if we try to observe the resulting right-hand side after the substitution, actually the first one is 0. Because f of 0 is actually 0, right? So this is gone. The second part is actually plus 1 times x. It is actually x. Okay, it is this. The third one, this is 0 over 2 factorial. 2 factorial is 2. 0 over 2 is 0. 0 times x squared. So this is actually gone. So the term with an x squared is missing on the sine function. Okay? Plus the third one, negative 1 over 3 factorial times x cubed. This is not 0. This is negative 1, right? So this should be 3 times 2 is actually 6. So since this is plus, this is minus, this should be minus. Minus 1, 6 times x cubed. Okay? The fourth one. The fourth one is actually 0 over 4 times 3 times 2 times 1. 4 factorial is actually 12 is 24. 0 over 24 is actually 0. And 0 times x to the 4 will be 0. So actually this term is missing. Right? Right? There is no x to the 4th on the resulting answer. The last part will be, this is plus 1, right? Preceded by plus. So this will be plus. All over 5 factorial. 5 factorial will be 20 times 6 is actually 120. So the coefficient of x to the 5th will be 1 over 120 times x to the 5th plus that. So the resulting, what they call this equivalent of sine of x by using Maclaurin series of expansion. This is a general formula. Sine of x in general now will be x, okay, minus 16 x cubed plus 1 over 20 x to the 5th. And if you notice it, under the sine function, the exponents of x are actually odd numbers, right? For the cosine, I think it's even numbers, 2, 4, and 6 going up. But for the sine function, it will be 3, 5. I think the next one will be 7 if we try to continue. But we stop at x to the 5th. Because up to x to the 5th, the resulting accuracy of the answer now will be, I think it's almost accurate. So we stop up to x to the 5th. So in general now, sine of x will be equal to x minus 1 over 6 x cubed plus 1 over 120 x to the fifth plus certain minimal values over here. So this is our first answer. That is the relation of sine of x by using Maclaurin series of expansion. So actually this is x minus 16 x cubed plus 1 over 120 x to the fifth plus that. So this is now sine of x, and the expansion by using Maclaurin's is x minus 16 x to the cube plus 1 over 120 x to the fifth plus that. And the next question on the problem is, if the value of the angle is 45 degrees, what will be sine of 45 degrees? So it's easy. When x is 45 degrees, okay, if we try to substitute this x here on the resulting Maclaurin's equivalent, it should be in radians. Just take note of that. You cannot just substitute the given angle if that given angle is in degrees. It must be changed first to the so-called radians. And we know that pi is 180, or 2 pi is 360. We divided by 2, therefore pi is actually 180. If we divide both sides of the equation by 4, pi over 4 will be 180 over 4, and 180 over 4 is actually 45 degrees. Okay, so the needed value which is to be substituted in the equation is actually pi over 4. Do not try to use 45 degrees. Try to take the radian equivalent, because 45 degrees is actually pi over 4 radians. So to compute now for the value of sine of 45 degrees, I will just go back here, then substitute the value of x in terms of radians. Right? Okay, substituting. Sine of 45 degrees will be x will be pi over 4 radians, minus 1/6. The value of x in terms of radians is pi over 4 raised to the third power, plus 1 over 120. The value of x in terms of radians is pi over 4 raised to the fifth power. Pi over 4 is 0.7854 by using your calculator. Pi over 4, you divide that, raise that to the third power, divided by 6. What comes out will be 0.07. And pi over 4, we take the ratio, we raise that to the fifth power, we divide that by 120. What comes out is 0.00249. Let's try to check. You display pi divided by 4 equals, we took the ratio already, y to the x 3, pi divided by 4 equals, okay, y to the x should be 3 instantly, raised to the third power equals, divided by 6, right, equals, what comes out is 0.0807. For the next one, it's the same. You just display pi divided by 4 equals y to the x. It should be 5, right? To the fifth power equals, divided by 120, divided by 120. The value is 0.00249. 0.00249. Right? So if we try to take the sum of these plus this is plus, this plus, it should be 0.78788. This is minus 0.087. And if we try to take the difference of this, okay, what comes out is 0.707. So sine of 45 degrees is actually 0.707, and actually that's the correct value of sine of 45 degrees. And if we try to check our answer, 45 degrees is actually a spatial triangle, in which the opposite side and the adjacent side are same in length. So if this is 1 and this is 1, the hypotenuse will be the square of this plus the square of this. So the hypotenuse is actually square root of 2. And this is 45 degrees. And sine is actually opposite over hypotenuse, right? So sine of 45 degrees, if we check the validity of our answer, it will be 1 over square root of 2. And 1 over square root of 2, by simplifying this, by using our knowledge of radical, we multiply this by square root of 2 over square root of 2. Okay? What comes out will be 1 times the square root of 2 is actually square root of 2. And the square root of 2 is 1.414. Right? And the square root of 2 times the square root of 2 is just 2. So this is divided by 2. And if we try to divide 1.414 by 2, the answer is actually 0.707. QED. Quod erat demonstrandum. It has been shown to be correct, right? Meaning, sine of 45 degrees, by using our knowledge of spatial angle, it is 0.707. And this is the same as the solution by using Maclaurin series of expansion. Okay, that's it, guys. That's the problem, okay? Looking for the what they call this equivalent of sine of x in terms of this, by using the so-called Maclaurin series of expansion. It is this. So try to memorize this by heart. There's no problem with it, okay? And when x is 45 degrees, by using this expansion here, it came out that the resulting answer of sine of 45 degrees is 0.707. And to check the validity of answer, the answer is still 0.707. Right? Okay, so for those of you who are taking advanced mathematics, this is for you guys. If you want to subscribe to my channel, our advanced mathematics long-form video content is almost done, right? This is for you guys. If you want to subscribe to my channel got some long-form video content and short-form video content, okay? And if you want to subscribe, my channel is at youtube.com/@ProfDavidJ.De And if you want to share it, please click share. Okay? Good morning from Los Angeles.